Okay. Good morning. Myself Dinesh Kumar from Energy Management Center. You're all welcome to the online course on ECBC compliance check through energy simulation. Today we have two sessions. First session is from 10:15 a.m. extending up to 12:30 p.m. in between we will hear from our director, Dr. R. Harikumar. Then the keynote address by the masterminds, one of the masterminds of ECBC, Mr. Tanmay Tathagat. After that, the sessions will be handled by Mrs. Samhidayam. She's an ECBC master trainer. She will be continuing through the session and also in the evening session. I need not introduce you regarding what EMC is and what EMC stands for, but still, as you all know, Energy Management Center is the state designated agency of Bureau of Energy Efficiency, Government of India. We are working towards energy efficiency and energy efficient use of energy in all sectors of life. This program is for those interested engineers who are interested to become experts in energy efficiency simulation for buildings in compliance with the Energy Conservation Building Code, which is enacted now in 2007 by the central government, and now in Kerala by 2019 November it came into force and made part of the state building rules. Let me invite Mr. Tanmay Tathagat, Director, Environmental Design Solution. He is one of the mastermind behind the formation of Energy Conservation Building Code. Let me introduce him to you. Tanmay Tathagat has a background of architecture and engineering. He has over 20 years of working experience in projects dealing with sustainable developments, building energy efficiency, green building and energy efficiency standards and labeling in Asia, Africa and the United States. He led the development of Energy Conservation Building Code and Eco Housing Program in India. His international experiences include support to energy efficiency building code development in California, India, Thailand, Philippines and Vietnam, and conducting energy efficiency training for building professionals. Mr. Tathagat is an acknowledged expert in building integrated design and energy simulation and has provided training and assistance to architects, engineers and facility managers all over the world. Tanmay leads the environmental design solutions team of consultants working on climate change policies, energy efficient building design, building code development, energy efficiency policy development, energy simulation and green building certification. Since 2003, the Environmental Design Solutions, in which he is director, has worked on over 500 green building and energy efficiency projects worldwide. Let me please welcome Mr. Tanmay Tathagat to talk with you, give you a keynote address on this training program. Thank you.
Thank you for that introduction, and we will go through a brief summary of understanding what I wanted to talk about is why. All right, so I wanted to go through the the value of having ECBC and how it affects the overall energy efficiency policy and the energy savings that one can achieve at any level. And for a building code to be effective, what are the implementation challenges and what really needs to be done apart from having the trained and expert engineers and architects to design and build. The energy code requires a whole ecosystem of policies, products, materials. So we'll quickly run through, and I'll be happy to get your feedback and questions later. So just to set the context, India is growing, and we're expecting, if you look at the next 10 years, another 1 billion square meters of commercial construction, which to a large extent is, we can see, is divided in offices, educational buildings, retail, and hospitality and hotels and hospitals. These are some of the fastest growing commercial buildings in the country right now. And if you look at the residential sector, as we just heard, that residential is growing even faster. And overall in the country, we're expecting there's a demand for over 10 billion square meters residential by 2030. So this is the total stock that we'll have by 2030. And if I look at it by state, Kerala is in fact is about 190 odd million square meters of building stock by 2030, which is quite intense considering that it's in terms of size, there are states which are much larger but with smaller building footprints. So this was a projection that we did for ECBC impact, and it shows the priorities that the government and the states have that push the building sector and setting up of new commercial buildings. So this is just a commercial building stock. Now, if I look at the role of this building sector, it's not just on energy consumption, but a large part of it is also contributing to the economy. So the target of the Indian economy is to grow to 10 trillion by 2030 or 5 trillion by 2025. Construction is already about 8% of our GDP and is expected to grow to about 15% of the GDP. So construction is a directly a major driver for the economy, for jobs, and for a lot of on-the-ground activities that drive our economy. So it is becoming even more critical as we go forward. We all know the environmental impact of buildings. If we look at a typical building that, let's say, a business as usual, you know, there's a lot of input that goes into making a house or a building. So there's building material, energy, water, all kinds of things. But in the current system in which we operate, everything that goes in as an input comes out as a problem to be managed. So building material end up as construction waste or demolition waste. All the energy that goes into the building comes out as wasted heat or emissions or pollution. Fresh water goes into the building, comes out as grey water or sewage. All the consumer goods comes out as waste. So the way we use our resources in construction sector like most other sectors, is a one-way process and creates a problem at the end. What is required for us to be sustainable, for us to reduce the impact of our construction, is to uh, close that loop as much as possible and close it locally as much as possible. So buildings that are energy efficient, that are self-reliant on, say, energy generation, have their own renewable energy source, close the loop of energy uh, at the local level. Similarly, uh, uh, the buildings that can have their own maybe ecological sewage treatment system can actually reduce the the effluents that go out to the city, the sewage that goes out to the city, and manage it better. So our attempt is to reduce the outflow uh, of pollutants, of things that can cause emissions, and ECBC is one such step in that direction. Overall, our projection for electricity use is very dire. And if I look at the NITI Aayog numbers, both residential and commercial energy use is going to be our biggest energy challenge in the building sector. So, as we heard from the director, that the biggest end use in most urbanized states and cities is going to be buildings.
It's 11 o'clock.
So, just all of you are very proficient with understanding of what uh, energy use and end uses are in the building. And we know that a building uses energy through different processes which are required to keep uh, people, the occupants, comfortable. And the major end users are air conditioning, lighting, and appliances to a large extent in most of our climates. What influences it and what can we do to reduce this energy use is in uh, in our control at the time we design and build the buildings, and also in the occupants' control on how they operate the building. We know that things like appropriate orientation and shading of the buildings, enhanced wall and roof insulation, efficient and shading, efficient cooling systems, good daylighting, and efficient lighting systems with controls are some of the most cost-effective measures through which energy use in buildings can be reduced. So the Energy Conservation Building Code uh, is uh, is a minimum efficiency standard for such commercial buildings. There's also an ECBCR or Eco Niwas Samhita, which is for residential buildings. So these two codes govern the energy use for both residential and commercial buildings and are the baseline, I would say, that said that this is the minimum that every building has to comply. The ECBC 2017, which you are going to be looking at through this course, was developed through a long and rigorous process, and it took almost 5 years for it to be updated. The first code for ECBC came out in 2007, and that also took roughly about 4 to 5 years to come up to be developed. And for ECBC 2017 followed a process in which the different aspects of building design, construction, material, and equipment were analyzed for cost effectiveness, life cycle cost, the most appropriate technology available, and based on that, it was updated through a consultative process. So the key provisions of ECBC 2017, which is the subject of this training program, that you will understand is that the whole code is divided in 6 sections: the scope, the compliance and approach, building envelope, the comfort systems and controls, lightings and controls, and electrical and renewables. These are divided further into sections of certain things that are mandatory and certain things that are prescriptive. It's important to understand that although the code has the option of compliance through a prescriptive mechanism, the simulation option gives a lot more flexibility, and the energy simulation option also presents more than the flexibility, a wonderful opportunity to do integrated design. So the value of doing what you're learning in this course is not just for ECBC compliance. I would really think that the moment we are equipped with the skills for doing energy simulation, the key aspect of that, and that we use in our practice, for example, is in early stage design assistance. Once I have the simulation skills, I can use it to say what should be the shape, size, and orientation of building, what should be the type of openings that are required, even before we do ECBC compliance. So this adds value in not just meeting the code, but actually doing an overall optimization of the building design. And the scope section deals with what kind of buildings are covered, and this again is specified in ECBC, and then every state has changed it to suit their specific requirements. So some have done it based on the plot area, some have done it based on the overall built-up area, and some have extended the type of buildings that are included. The compliance and approach section has a few important things. One critical aspect of ECBC is that the legal definition of energy conservation building code that comes out of the Energy Conservation Act 2001 states that the ECBC will be expressed in terms of energy use intensity. That means energy use per square meter of the building per year, kilowatt hours per square meter per year. So even when we follow the prescriptive norm, the code is ultimately trying to show compliance through an EPI method, through saying that energy use intensity, EUI, or energy performance index, EPI, those are the two terms that are used, are the metric through which the code will be tested. There are also distinct compliance methods for new and existing buildings, for mixed-use buildings, and that is coming to be a very important situation where you will find more and more developments where it's difficult to classify the building only as commercial or residential or hospitality or retail. They're all multiple functions in a building. So the code gives us a provision for how to comply with such situations. Also, what happens when the developer is only making core and shell, and the tenants will do, say, lighting or air conditioning in certain cases. And the last thing is that the code ECBC is synchronized with the National Building Code, the Standards and Labeling Program, the PAT scheme, and other programs that are there at the national and state levels. So minimum design standards are referenced from the National Building Code. So for example, what should be the design criteria for, say, comfort, or for lighting, or for ventilation? Those standards are all set by the National Building Code, and ECBC references those. So it does not duplicate it. The code does not tell you that your lux level has to be 300 or 500, because those are coming from the National Building Code. This standard will only tell you what is the energy efficiency requirement for meeting that certain performance level. So when you're looking at a code compliance, although it is not written in the code in ECBC, you are assuming, and one should always check, that the building design standards are appropriate and as per NBC. The next section deals with building envelope, wall, windows, roof, efficiency of climate, building types, and depends on the type of building. There are integration of passive design measures, and one of the few, in fact, it's the only building code of this kind in the world that mandates daylighting. And daylighting has a direct effect on the shape and size of the building, and the type of glass that is used, and the number of windows that one has. So I would say that the understanding of daylighting is extremely important for us to understand ECBC. And I would also suggest that the code be understood along with some simulation for ECBC and daylighting. Then we have the section on HVAC, which is predominantly on comfort systems and controls, where again the focus is both on natural ventilation, thermal comfort, and the code for first time again has an alternative for system efficiency. So if you don't want to look at efficiency of each component, let's say in a chilled water system, you can actually, and it is the preferred way, and the future of the code will mostly be dependent on the overall efficiency of the system rather than just the components. The code gives you both the options. Also, if you're using alternative methods of cooling that are more efficient than the conventional approaches like geothermal or solar-based cooling, or some combination of new technologies that are there, like radiant cooling, then you are exempt from some of the prescriptive requirements of the code. On the lighting side, there's a lot of focus on not just technology, but also on controls, because efficient lighting is dependent on both how the lighting is installed and how it is operated. On the electrical side, there's integration of renewables so that the future buildings are ready at the very minimum to get renewable energy integrated. And at the same time, we are poised to go towards net zero energy buildings. So the potential impact of this code is immense. There's minimum compliance to ECBC is typically 25% lower energy use than a standard building which is being built today. One of the unique things about this code is that it has two other levels. So ECBC is the minimum standard. ECBC Plus and Super ECBC are the enhanced standards, and Super ECBC is gearing towards a net zero energy building. So once you achieve a Super ECBC, that means as per current technology available globally, the building is as efficient as one can make, and the rest of the energy can actually be met through renewable energy source to go towards net zero. In a typical building, ECBC and Super ECBC by different climates, you can see that the percentage energy saving varies, and in climate of warm and humid, where the most of Kerala would fall, you are looking at 26%, 36%, and 49% savings on an average across building types, based on business as usual as of now. If I look at the energy performance index, this is for the country and weighted by stock. So if a typical building right now has an energy use intensity of roughly 200 kilowatt hours per square meter per year. So this is a weighted average of all building types: hotels, hospitals, offices, except for non-residential buildings. Then ECBC building will typically have an EPI of 152, ECBC Plus of 130, and Super ECBC of 104. This includes all energy end users in the building. So you clearly see there is a tremendous savings impact at the building level for the end user. One of the key questions is that we have all the time when it comes out is, what is the cost benefit of doing this? And when we did this impact assessment, we saw that that typical building by today's budget will have an increased cost between 1 to 4%, depending on what their baseline costs are. And if I add the savings to over the lifetime of the building and on the energy use for the country, the cost benefit, and if I can translate that in rupees, is cumulative. And you can see the bottom bar, the gray bar, is the total investment, and the top bar is the cumulative for that year. What is the saving in overall cost to the country and to the individual? And you can see that there is a multiple fold impact of this. So it has two impacts. That means that not only are you saving energy, you are saving a lot of cost for the country, which can be put to better use. And then if you go towards Super ECBC, that multiplication, that multiplier is even higher. So I quickly just want to, in the last few minutes, talk about what is the key issues of implementation. And we heard in the morning that there are three, that ECBC has been notified and it has been now put under the municipal rules, and the local government units, LSGs, are now equipped to legally start doing the code. So as far as we know, that the state has adopted the ECBC. But the next two steps are where we are right now. So I just wanted to quickly see that there is always an understanding that one needs to have, that there are three stages of completely integrating ECBC into the state bylaws. One is the adoption, where you take the ECBC, change it to the local climate conditions, and notify it. And this is the stage that we have reached right now, where the legal provision is clear. But the next important step, and this is where most of the effort needs to go, is the compliance procedure. So once the legal procedure is clear, what is the process for compliance? If a builder, developer, owner, architect, engineer has to submit an application for a new building, how does ECBC fit in? Where do they go to submit their application? What is the format for that application? What information is required? What is the fee? How much time it will take? These are the compliance related issues. What tools and software are applicable? And finally, who is the right person to approve these things? And this is where this training is going for certified ECBC compliance. And this is the stage we are in right now. Once this is clear, then I can clearly and confidently say that ECBC is being taken up by the state. If I just do the rules and notification, that means I have only made the legal provision, but the compliance mechanism is not yet in place. And the last part is enforcement. So once all of this is done, then you need to have an enforcement mechanism that says, how do you check compliance on the ground? How do you verify that things are being done? And how is that information coming back to me so that our compliance mechanism can be improved? So if I look at the steps in this, you don't need to get into the detail, but there are several steps of compliance. And the critical steps for us is to frame the compliance mechanism, identify the jurisdiction, who does what, and if I have that clear, then I can say ECBC. Then we come into compliance, measurement verification, audits, annual checks, and all kinds of things later on. So these are the 5 steps that I said: adoption, amendment, compliance enforcement mechanism needs to be clear, a structured implementation program with time-bound execution, and finally, the implementation, enforcement, measurement, and verification. So the key barriers, we know why these things don't happen. Municipalities and agencies have to coordinate because buildings are a municipal subject and ECBC comes under a different department. They need to be coordinated both in terms of implementation and execution. Electricity rate structures and subsidies, sometimes in commercial buildings, the utilities are not interested in reducing their revenue by reducing the energy use in buildings that are actually significant revenue generators, and it's always a problem in many areas. And finally, lack of government or a utility champion, because this is a complex subject and somebody needs to be really a champion for this. And finally, of course, if the enforcement mechanism is not clear, then it creates a lot of confusion and people are not really able to comply. Market barriers are always there. People will always do what is the cheapest to do in the first cost, even if we talk about a life cycle cost. And there is a split incentive for a developer. He says, okay, why should I do this code when all the savings will go to the occupier? So what is required is at the state level a mandatory program which includes ECBC for all new buildings and an energy labeling for all existing buildings, so you cover both design and operational efficiency. It also means that you need to have a comprehensive approach which is driven by the user's demand, by the occupant's demand and their comfort. You need to look at new and existing buildings through a different lens, but both need to be covered. It should fit within the existing policies and legal mandates. We should not be creating more laws because there's already a lot of regulations that the building industry faces already. It has to be market and consumer centric. As I said, the decisions and the investments come from the consumer and the products and equipment come from the market. So any decision we take on enforcement and implementation needs to be done with them in mind. It needs to be transparent, and it needs to also have incentives for people who go beyond the code. I think that for us has always been a good spot, where in India has been leading in green buildings and platinum rated buildings and 5-star rated buildings, because people really like to go beyond the minimum standards. Even in building code, that should be encouraged and incentivized. And finally, in this era of IT and smart building compliances, a lot of this can be online, IT enabled, and hassle free. Government leadership is the key. EMC, of course, has been pioneering one of the, they were part of the ECBC development. Even in 2007 and later in 2017 codes, EMC had a big contribution. The state has a big contribution. So the integrated approach for energy efficiency has to be not just for ECBC at the house or at a commercial building level, but needs to go through all the construction related activities. It has to integrate with key ministries that deal with key departments that deal with urban development, power, renewable energy, and environment, has to mandate all for all buildings. And the main thing which drives this is a clear vision and a long-term strategy. If you keep changing things on a day-to-day basis, it really gives a wrong signal. So we would like to have a clear long-term vision and says, okay, this is where we are going. And then the building material products, everything, and the architects and engineers also know where the industry is headed and are prepared for it. I see that Kerala is taking a lead in this direction, and it probably be one of the pioneering states that can actually set the standards for the rest of the country to follow. Thank you so much. All the best. I can see there are a few questions that I can see. One is about three major end users of electricity. So it's air conditioning, lighting, and the last one is the appliances or the equipment that users bring in. So if I look at a commercial building, apart from air conditioning and lighting, all the other products, equipment, laptops, copiers, let's say in a hospital, all the medical equipment, those are called the equipment or the plug loads that that are there. There is some questions about tenant occupied buildings. So, technically, this is a regulatory process. The requirements stay the same, but what the expectation is that in the rules that are framed for compliance, the owner has to take the undertaking that they will put this as a mandatory requirement for the tenants to meet the ECBC as a part of their lease agreement. And that has to be shown by the owner at the time of compliance and has to be verified later. I think Kerala, like any other states overall in the country, there's a question about which sector is using more energy, residential or commercial. Overall, globally as well as in India and in Kerala, residential uses more energy than commercial, just because the sheer number of residential, the square meters of construction of residential is a lot more than commercial. So residential uses a lot more energy. Coordination with ministries has to be at both levels, but essentially there is a question about which agencies need to be involved. At the state level, it's actually more important because most of the building related rules and bylaws are at the state and municipal level. So if at the state level, the urban development and the power or energy, as it is called in a few states, are coordinated, then majority of these problems are actually sorted at that state level. Of course, it also needs to be done at the central level, but it doesn't automatically translate into state action. is saying ECBC says, sorry, is it time? Yes. So I think ECBC needs to be updated every 5 years at the very latest. And that's why the current ECBC, there are 3 levels built in. There is ECBC, ECBC Plus, and Super ECBC. So if in 5 years, the next level should automatically kick in. So by 2022, the ECBC Plus level should become the mandatory standard. So that's the idea, that it scales up, and the next version needs to be absolutely. In fact, most countries, the update and the changes are notified every few years, and the process is continuous. Thermal energy integration will consider only in the building envelope. Yes. Is there any structural stability analysis? No. Structural stability is not covered, and it is assumed that it's a part of other codes. Okay. I think those are all the questions. If there's anything else, I'll be happy to address later, or back to the organizers. Thank you so much.
Thank you, Tanmay sir. It was a very informative session. Thank you for taking your time for giving us this wonderful session. Thank you.